speak will be starting in the next couple of minutes. Thanks. Designing a cloud-native roadmap for enterprise applications. Also, another title, which I stole from Jason, our analyst, is the Enterprise Application Migration Challenge. And we're real excited today to have Jason Bloomberg, who's the president and principal analyst of Intellyx. And he's a leading industry analyst, author, keynote speaker, globally recognized expert on multi-disruptive trends in enterprise technology and digital transformation. Plus, he's a good guy. And also, we're real happy to have Simone Sassoli, who's our Chief Customer Officer. He's responsible for go-to-market and support activities to help customers solve fundamental deployment challenges for big data, databases, search and indexing, AI/ML. And he's also a 20-year veteran of this space. So first, let's just do a little bit of housekeeping. We'll move the slide. Pretty standard. All the lines will be muted. We ask that you please put any questions into the Q&A box, and we'll try to get to them at the end of the presentation. We're going to leave 10 minutes or so to get through as many questions as possible, and then the others that we can't get to, we'll follow up with you. And of course, the webinar will be recorded, and we'll forward the recording to everyone that's registered. So without further ado, I'd like to introduce Jason Bloomberg to take it away.
Thank you very much, Tim. So as Tim mentioned, I'm president of Intellyx, an industry analyst firm focused broadly on digital transformation in the enterprise. We also published our Agile Digital Transformation Roadmap poster a few years ago, and I'll have the URL for downloading that at the end of my talk. So we're talking about migrating enterprise applications. So what sorts of applications are we talking about? And when people think about migrating applications to the cloud or to cloud native, the conversation often begins with the monolith. So what is the monolith? Here you see a monolith. And typically these are legacy applications that are coded as a single unit, and they can be difficult and inflexible to do really much of anything with. They may not have APIs, they may not be modular in any way, and the coding may be difficult to work with because it may be so old. But that's not really the whole story, right? There are more enterprise applications that we're considering migrating to the cloud or to cloud native infrastructure than this typical monolith story. So that's part of what we'll be talking about is the broader variety of applications. So when we talk about cloud migration or cloud native migration, I guess the first point is that these are different things, right? We can take a legacy application of some sort, some existing on-premises application, and we can move it to the cloud. And there's pros and cons to doing that, right? We get the advantages of cloud computing in terms of the pay-as-you-go pricing. You let somebody else handle the infrastructure. But whether or not we get the elasticity and scale depends upon how well we've architected the application for the cloud. So there are challenges there. Not every migration gives you the ROI that you're expecting. Well, now migrating to cloud native would be an additional step where in the cloud, presumably we have Kubernetes, the most popular container orchestration platform, and we may be running that in the cloud. We could run that on premises as well, but typically we run it in one cloud or another, either a public cloud or our own private cloud. And now the question is, well, are we going to take this on-premises app, which again could be a monolith or perhaps some other kind of on-premises app, and are we going to put it in this containerized environment as well as being in the cloud? And it's not the same thing as simply moving to the cloud. Most cloud migration is moving to virtual machines in the cloud, which is different from moving to containers in the cloud, because containerization requires a rethink of how the code is constructed, but also rethink of the overall infrastructure supporting the application in the cloud. So there's some subtleties to what we mean by cloud migration, cloud native migration, and that's what I'll be getting into. So when we talk about migrating to the cloud, one of the most common business benefits is lower capital expense, or CapEx, right? You don't have to buy your hardware anymore. So instead, you're paying as you go for your cloud provider's hardware, whatever part of it that you need to use. You're paying, on a per minute basis or whatever the deal is. So you don't have that capital expense. Presumably, you have unlimited scale. Of course, there's no such thing as true unlimited scale, but all the scale that you need That's one of the benefits we're looking for from the cloud. And we only use what, we only pay for what we use in theory. It can be tricky in practice, but we hopefully will get better utilization. And of course, we have the self-service benefits of being able to interact with the cloud on our own. We don't have to get a third party to do it for us. And then we have elasticity in minutes, and this is an important point, right? The cloud is elastic, right? We have a virtual machine and it starts reaching some sort of capacity limit. We can provision another virtual machine, another instance, another node in our for our application, but it typically takes minutes to do that because we're building this whole operating system and application environment, and that's not something we can do faster than typically, some number of minutes. Now, cloud native, where we're moving to a Kubernetes environment, typically in the cloud, well, this will actually lower our operational expense, or OPEX, because we're actually being more efficient with how we leverage our code-based assets, right? Instead of having to move some big block of code to a virtual machine, we're now thinking about microservices, which are smaller units of code, and managing them on a much more efficient basis. So if we figure out how to get Kubernetes to work for us, we have lower operational cost as well as the lower capital expense that the cloud gives us. So cloud native also gives us greater flexibility and availability over just moving to the cloud, as well as improved parallel development. And this is an important point and one of the most strongest business value propositions of moving to cloud native is because we're modularizing the code better and we're building code in smaller units, the microservices, that if we get that right, and that is a big if because there's a lot that goes into that, but if we get that right, we now can have more people working on large applications at the same time because they're working on modular pieces of those applications more in parallel than perhaps they could with a monolithic application where really you have one team working on the whole thing, because if you have different people working on different parts of it, they'll step on each other's toes. So ideally, we have better parallel development, which means we can have larger groups of people working at the same time, which means we can get more done. And we're achieving the benefits of continuous integration and deployment, the DevOps benefits, and we can scale that more. So we're scaling our teams as well as our infrastructure. And then finally, elasticity in cloud native works on fractions of a second as opposed to minutes, right? Provisioning additional containers, typically, it takes just a split second, and there's smaller amounts of code goes into them. So we can scale up and scale down much more quickly, which gives us much greater flexibility as to how we used elasticity in how we plan for and account for the changing needs for our application. So it helps us rethink what elasticity means for us in terms of the business value that we're getting from our technology. Okay, so I've used the term cloud native a few times. It's time to put a finer point on what we mean by cloud native. Essentially, what we mean by cloud native when we talk about it at Intellyx is that we are taking the core best practices of the cloud and extending those to all of enterprise IT. So it doesn't even necessarily require that you're running in the cloud all the time, right? Because you're extending cloud native computing to a hybrid environment if that's what's going to meet your needs, where hybrid now is a combination of public cloud, private cloud, and on-premises assets. The key is that now that if we have on-premises assets, we're applying cloud best practices to them. So we want them to be scalable. We want to abstract them so that we have self-service control. We want to have pay-as-you-go pricing and all the other aspects of the cloud, but we're bringing those to on-premises assets, virtualized assets using traditional virtualization, containerized assets, and even serverless assets as well, which is a part of this broader cloud native trend. So we get all of these benefits of the cloud, but we don't want to just do them in the cloud, right? Although typically we're in the cloud, but we don't necessarily want to require that everything be in the cloud. For many enterprises, they're looking at the cloud and saying, oh, the cloud can solve many of our problems, but there are reasons to do some things on premises, and we're doing that intentionally on purpose for compliance reasons, for cost reasons, or other reasons. And cloud native computing can now give enterprises with both on-premises and cloud-based assets a coherent, end-to-end comprehensive approach for managing, for running, for developing software, and for achieving these elasticity and flexibility benefits that are so important in today's world. So When you look at cloud native infrastructures now, there are some key characteristics that are part of this cloud native story. So the first is that many of the assets are ephemeral. So ephemeral is essentially a word that means that they are designed to exist for a limited amount of time. They're not designed to be permanent. It's essentially the opposite of permanent. So microservices, containers, and pods, which are sets of containers in the Kubernetes world, are designed to come and go based upon the needs of the application and, by extension, the needs of the business. So this is all central now to how we think about the assets that we put into a cloud native environment, right? If they can come and they go, then we can't store things in them that we want to keep around, and this impacts how we deal with state information, and I'll get to that in a moment. So cloud native infrastructure is inherently dynamic, right? Things change all the time, and the technology supports the level of change that we require. So not all applications require, second by second change. We're not necessarily deploying every minute, but if we need to, we have that ability to, and we are now able to support whatever change is required by the business. Real-time behavior is also a characteristic of cloud native infrastructure, where we're expecting everything to happen right away, right? We're not necessarily queuing things up to happen later. We're not following a batch approach or a polling approach, but we're expecting scalable processing to happen on an ongoing basis in a stateless environment, right? We're not keeping track of anything. Essentially, we send information to a microservice, it does what it's supposed to do, sends the result along without stopping and storing anything anywhere. Then observability is the fourth key characteristic, where this is essentially central to how we monitor and manage the cloud native infrastructure environment. That monitoring is part of the story, but we also need to give our operators abstracted control over the infrastructure. So it's not just watching what's going on, it's not just having the better dashboard, it's also giving the operator greater control so that they can actively manage and maintain the infrastructure, right? It's great to say that all of this stuff is dynamic and ephemeral, but we still need human beings to make sure everything keeps working properly. So let's take a look now at what we mean by cloud native migration. So as I mentioned at the top of the hour, monoliths are part of the story. We may have these older legacy apps that are just not very modular. They may have other issues, but more often than not, we have an app like the one on the right. And this is, you may recognize the MVC or model view controller pattern, right, where we have the presentation tier, for instance, a browser, but not necessarily a browser. It could be an IoT device or anything that might go on the presentation tier. The application tier, a typical example would be Tomcat, but really could be anything running in that middle tier. And then the database, something handling persistence under the cover. So we have this 3-tier or MVC architecture, and that's the typical generally speaking, logical architecture for any web-based application. So we've been using web-based applications since the 1990s, right? They're established best practice. We know how to scale them, we know how to run them, and they've become essentially the typical application architecture for many different applications that may now be, a decade or two old. So they're not necessarily brand new, but it is very typical. And now we have a level of modularization that is built into the architecture. So even though we may be talking about migrating these monolithic applications that we had many years ago, more often than not, we're migrating more modern architected applications. It gives us greater flexibility in terms of the modularization of the software that we're dealing with. So that's an important point as well. So I talked about on the last slide N-tier architecture, or 3-tier as in the illustration, but really 3 is an arbitrary number. We could have more than 3 tiers, so N-tier architecture. And this was very popular, as I mentioned, in the 90s. In the 2000s, we had the rise of service-oriented architecture, where we are abstracting legacy assets as XML-based services, web services, and then we were integrating based upon these essentially dumb service endpoints, and our intelligence was now in the middleware. So we had smart pipes and dumb endpoints. That gave rise to microservices architecture, and this is basically part of the late 2010s, where now we were thinking, well, web services that were XML based had limitations. There were problems getting those to achieve the benefits we were looking for. So microservices are units of execution. They're more than just the XML part of the story, but it's the actual running code as well. And this gave us greater flexibility. But microservices alone still have challenges, right? We still had problems with scaling. We still had problems with managing, how many microservices do we have? And if they're all talking to each other, we end up with this big tangled mess. So microservices architecture had its limitations. And that really gave way to cloud native architecture, where we're saying, well, we're going to orchestrate our microservices in a standards-based way, leveraging open source technology in the context of cloud native computing, which is more than just our applications and our code. It's this broader story that touches upon how we deal with security, how we deal with overall infrastructure, and how we deal with the hybrid IT context for the cloud native story. So there's a lot of different ongoing improvements that have been going on. And this is important for a number of reasons. One is that cloud native is really the latest and greatest part of the story, and we've actually been making progress. Even though microservices may resemble web services, they're different things, and they are different for a reason. And what we're doing in the cloud native world is, again, the latest generation of enterprise IT best practice. So if we apply this cloud native principle to our N-tier or 3-tier architecture from a few slides ago, well, when we migrate to Kubernetes in a cloud native environment, we're really taking a different way of looking. We're having a different way of looking at each of the tiers, because we want to abstract each element of the story. So if you remember, we had the presentation tier, the application tier, and the persistence tier, which you could think of as, the compute and the storage as well as the presentation. But we took the network for granted. In an N-tier architecture, we take the network for granted. We know we have to have load balancers and other things as part of our network. In the cloud native world, the network is now a first-class citizen. So we're abstracting compute, we're abstracting network, and we're abstracting storage. And all of these abstractions are configuration-based. So we have configuration or metadata-based context for how we're dealing with all elements of our architecture within the context of the Kubernetes environment that is managing now all of our software resources in a comprehensive way. So we still have hidden in here the N-tier architecture if we want, right? So migrating an N-tier application to the Kubernetes environment is basically saying, well, let's make sure we have our abstracted client represent our existing client, our abstracted storage representing our persistence tier, and then abstracted application is part of our microservices infrastructure here represented as Kubernetes clusters, and then we're also going to abstract the network as well. So that should suggest to you that yes, there is an upgrade path that makes sense, but also there is a reasonably high level of complexity. And anybody who is worked with Kubernetes, especially working with Kubernetes at scale, will be the first to admit that there is a lot of complexity here, that we've solved a lot of problems with how Kubernetes deals with the world and how cloud native infrastructure is piecing together, but there is enormous complexity. Even if you get everything right, it's still complicated. And this is an important point, because this ties into the second half of our webinar, is how do we deal with that complexity, given that even if we have an application that is well architected to move to the cloud native environment, it still involves a lot of complexity because there's so many moving parts, and we're abstracting each of those parts in turn. So that's something to keep in mind. So cloud native context, cloud native architecture context. So if we're looking at the architectural context for cloud native infrastructure, we have what I like to call the 3 lesses. So stateless, codeless, and trustless. So we're not meaning to say that we don't deal with state information, we don't have code, and we don't have anything we can trust, but rather these are architectural principles that we now have to address. So statelessness essentially means that stateless processing is the norm, and now we have to deal with state information in an abstracted way. So instead of simply having storage, we're simply storing things in microservices, which give us problems because they're ephemeral. We're going to have abstracted storage that we deal with via APIs and via the stateless properties of our Kubernetes infrastructure. Codeless essentially means that it's configuration driven. You can think of this as the extension of infrastructure as code. although we're taking that to the next level and saying infrastructure as configuration, where we're configuring everything. This could be YAML files or Helm charts or other forms of metadata that essentially describe the entire infrastructure environment, following a cattle not pets metaphor, if you're familiar with that, right? We're not going to go into the infrastructure and tweak things manually, but rather we're going to, if we need to update something in the production environment, we'll make a change to the metadata, change to the configuration, and redeploy. Redeployment now is even simpler because we're in an inherently ephemeral environment. And the trustlessness is a bit beyond the scope of this webinar, really focuses on the security part of the story, taking what we had called zero trust, which is now over 10 years old, and adding abstracted endpoints to it. So it's basically saying we're updating a zero trust story, which has been a long time best practice, but updating it for the cloud native world. So state information in particular is a key part of the story. It's something that Robin does very well, so it's worth emphasizing. We need to manage state in a stateless environment, largely API driven, but there's another part of the story as well, and that is the rise of service meshes, which help us deal with essentially east-west communication, that is microservice to microservice interactions in an abstracted way. So this is a key part of the story as well, where we don't want to rely upon the microservices themselves to deal with state information. So we're going to rely upon the service meshes and abstracted persistence tier in order to support our state information within the entire cloud native infrastructure, both in the cloud on a Kubernetes, as well as hybrid environments that include public-private cloud, as well as on-premises environments. So it's beyond just Kubernetes. We want to have an abstracted way of dealing with state information across all of our IT infrastructure. So one of the key questions that you're going to have as organizations when we talk about migrating applications to the cloud or migrating applications to cloud native is it really the right choice? It may sound good. Oh yeah, we want to move to the cloud. We want to move to cloud native. Kubernetes is cool. Let's do it. But you need to make a real business decision, right? Is it the right choice based upon all of the pros and cons, including cost and human issues, right? How much time, how many people you're going to need, and how much of their time are you going to need to get all this stuff to work? So you have to think about the benefits of moving to the cloud. If you're re-architecting your application, you have to think about the costs and risks involved, and does that make sense for given the business value that you're looking to achieve? And you need to think about how you're going to deal with the human side of things. You know, if you're doing taking a DevOps approach, well, that's a human-centric approach, right? Automation-driven, but really about human collaboration. How are you going to support that in a cloud-native environment? How expensive is that going to be for you? All of this is part of the story. So one of the key questions you need to ask is, well, are there ways to lower the risk and cost of re-architecting applications if we want to move them to a cloud-native environment? And that is the key question that you need to ask, because that's really where Robin fits into the story, is they're helping you reduce the cost and risk of moving to cloud-native because they're simplifying that re-architecture step. And that's something to keep in mind as you go through Simone's presentation. Look for those re-architecting pieces. What does it mean to changing the application I have in order to get it to work, and what do I need to do? And that's one of the key questions that you should be asking. So we need to place Kubernetes into this broader cloud native context, which is not just about technology, not just about containers, but is this overall enterprise IT story, which is not just technology, it's also the human side, driven by business needs with an eye for managing cost and risk. So that is basically my talk. So there's my email address. I'm at the eBizWizard on Twitter. If you want a copy of the poster, you can go to agiledigitaltransformation.com. So at this point, I will turn it over to Simone.
Thank you, Jason. It was a perfect setup for where we're going to go next. And we're going to put what you have presented in the context of the Robin platform and what it means to take the combination of cloud native applications as well as those who are not born in the cloud, because at the end you learn that actually Robin, it's an equal opportunity platform. So not only stateless or stateful, but also those that may be called legacy will apply in our platforms. We are starting from the stateless side, where we know how the benefits of Kubernetes brings to stateless application, where it can be cost efficient by sharing the cluster for multiple apps. You can be productive in the context of DevOps for an agile environment. You can go to full automation for life cycle of the application itself, and repeatable and automatable for day two operations. And then you have, on the other side, the stateful applications, which typically lives outside of Kubernetes. So it doesn't matter what type of apps you have, but you connect your stateless to your stateful, and they reside in a different place. And the issue you have is that you have a higher cost when it's deployed in silos. The rigid deployment impedes innovation. It takes days and weeks for lifecycle management to request the resources that you need for a quick deployment. That may be a development of an application that you want to just create very quickly and then tear down, in the context of an ephemeral load that is dynamic in nature. That is very difficult to do. And you have very separate manual operations when you try to maintain the two. So even though you may have Modernize and have microservices on one side, the typical big data time series, NoSQL and databases remain in a different place. So how do we go about at Robin to solve this? So central to the solution, we have Kubernetes as a container management system that is paired with application-aware storage. So this is where we bring all the goodness of what we know about, a very solid storage stack in the context of an overall platform, but also consider virtual networking as part of the solution. So you have what has, taken a lot of time to set up into an environment that would have required possibly, 2 or 3 or 4 different teams within an organization to bring this together. Now this can be deployed, through code as automation that brings the infrastructure back together. On top of it, then, you have your application workflow manager that allows you to then manage the application themselves in the context of how they are deployed in best practices, and therefore just giving something that with a one-click opportunity to not only deploy, but also to manage scale up, to do snapshots, to do upgrades and backups. It brings the full automation of the complexity that you may have with the different solutions. So let's talk about then, how does it manifest itself, right? We talked about, creating applications that are managed in a certain way. And we are trying to bring to the market something that allows a IT as a service. So the application presented in a marketplace, into an app store, where you have bundles, they are prepared, can be a single application, can be a concatenation of apps. And ultimately, you don't really, you worry about, for example, in the financial industry, about fraud analytics or deep learning or real-time risk detection. And every institution may have a different way to look at it, but there are some fundamental building blocks underlying that are a combination of applications that are stateful and stateless that you can pull together and manage at a single app. So this is where we're going to go into a little more details of, bring in this solution and what it means to manage them as a single app. In addition to that, you want to do it in a multi-tenant environment. You have many different users in the organization. You have many different applications, and you want to go through a DevOps front-end environment where you have development and test, and then move in the same way to a production environment. They may or may not leverage necessarily the application, where you may have a tendency to say, once I am locked and loaded, I can actually go back into a VM or into pure bare metal implementation. But until that point, I'm just going to use a much more agile DevOps element in the front end. And it gives you a lot of it gives you the ability to do physical isolation for resource pool. You can restrict users. You have tenants and application with specific resource pools, and the logical isolation themselves in terms of what you can do as a tenant, as a user, with all the elements that come from user authentication and role-based access control that lets only certain people do certain things, both at the platform level and the application level. So let's go for a second. Okay, so back into Jason comments. There are a lot of elements that need to be pulled together. There are different architecture you need to consider. And we're trying to make it such that once you deploy the platform, then you can make a decision on what type of application you want to deploy. So you may have compute nodes only, you may have storage node only, you may have converged nodes. So you start by having your scale-out storage that is common to any of the application you can deploy. Then you're going to have an application-aware networking that connects all of the different elements within the network itself and to the endpoints for the users that need to connect to the specific applications. On top of which, you have the programmatic elements of the application knowledge of the deployment, the rules, the placement, affinity, anti-affinity. Do you want them in a single data center, multiple data centers? You're going to go on-prem, they're going to public cloud, and we're going to just go to a stretch cluster across my different infrastructure. Those are all the questions that programmatically we can address and create an automation that will deploy for specific application on any on-prem or public cloud environment, being bare metals or VMs. You're looking at things that may take weeks, literally, if not months, sometime to do, and getting to an installation deployment of application literally in few minutes. And we have many of our customers that can attest to the simplicity of the solution, and in certain instances, the elegance of how it's brought together. So how we do this? So it is done in the standard Kubernetes, where there are Robin components that come into place. And let's go back to the combination of legacy versus modern apps. And one thing you're seeing here that is important, I'm using this a little more technical diagram, not that technical, but it shows the components to make up the Robin solution, is that we support Docker, LXC, but also virtual machines. Because not everybody is going to be able to modernize the application all at once. But you still want to combine this application into a bundle that allows you to take not only just a data snapshot, because that's typically what people refer to when you talk about snapshots and clones. We're talking about data, metadata, configuration, and all of the elements that are allowing you to take the entire application stack and possibly even migrating it into a cloud, as is, without making any underlying changes to the way it works. And we are managing virtual machines, not in containers. So it's just pure virtual machines that exist on their own, that allow you to put in even a legacy application, that particular context, that is connected to others that actually may be containerized and run with either already existing automations, Helm charts, or user Robin bundle constructs. So we have thought about how are we enabling enterprises to combine in their voyage how they're going to modernize this and how to coexist elements that have not really been thought through when Kubernetes was first coming to market, and we have tried to solve that solution so that we can help those that may be hesitant to really go very fast into re-architecting for microservices of all their applications. So what do we bring to the solution? And developers' productivity is what we focus on. So it's, of course, we talked about CapEx savings, we talked about OPEX savings, but at the end of the day, we want you to concentrate on the top line, which is you build an application for end consumers or internal consumers, and that's where you should be spending most of the time, so that we can have a self-service portal that can give you a database as a service, machine learning as a service, big data as a service, all elements that you can bring and deploy with one click. Deployment, protection, recovery for all of the application entirely, not just for the data itself. And this is going to allow you to do, dev tests much faster. The loads are ephemeral. You can, set them up and turn them down very quickly in such a way that you can think of ways of utilizing the data and moving data between even countries without the significant cost and timing that may have been involved in traditional method of deploying applications. And of course, you are optimizing your IT spend because you are utilizing your resources much more efficiently. You can pack 3 to 5 times up more applications and infrastructure, and you can reduce the footprint of the infrastructure itself significantly. And then we talk about, avoiding lock-in in public cloud. So there is a lot of talks about even moving to the cloud, but we want to be able that you can architect the solution for your on-prem and then using the public cloud as infrastructure and using the same exact construct, you can redeploy them onto a public cloud so that you can, again, use them in different ways, either as primary development and testing and or production. And that's going to allow you to just choose, for latency, for cost reasons, and many other elements, what is that you're looking for. So finishing, to learn more, you can access the resources on Robin.io. We have blogs, we have videos, we have ways that you can go in a little more depth, and we'll be glad for you guys to sign up to a demo, and we can teach you more about it. So I'll open up for questions from here.
Simone and Jason, thanks so much for the prezo. Again, sorry about that blip in the middle, but that happens when your presenters are all over the world. We did get a bunch of questions in. We'll just take a few minutes to whip through some of them, and hopefully Jason and Simone, you can field a few of these. The first one that came in is, I understand how cloud lowers CapEx. How does cloud native lower OPEX? I'll give that to Jason.
Yeah, I mean, it's sort of a subtle point because you're focusing on CapEx because, cloud native typically runs in the cloud and you get that advantage. But if you think about the advantages of having an ephemeral microservices application architecture, essentially you're running just the code that you need, right? You don't have code that you're running that is in excess of what you need. So you have the utilization challenge of cloud computing, right? You can provision a whole big instance, and then maybe you're using up the whole instance, and so you're spending money on underutilized resources. So you're saving that, but then you can be even more efficient because you can have just the the capabilities that you require, depending upon how you're leveraging the underlying infrastructure. And this is part of how serverless computing can help as well, right? If you have a serverless component, you're only paying for the invocations of those functions, essentially. So cloud native computing gives you greater options for reducing your operational expense.
Right. Another one, someone was a little confused. They asked, what do you mean by codeless and trustless?
Yeah, codeless essentially means that we're focusing on the configuration as opposed to the code for describing the behavior of our applications. So the microservices themselves are still, written with code, however you're writing your microservices, but the deployment of the microservices is done in the context of a configuration. So it could be how the Docker containers work, it could be how the Kubernetes container orchestration and the pods and clusters work. All of that is configuration driven. So what we have is this entire infrastructure now that is described via different forms of metadata. Simone mentioned the Helm charts, but it could be YAML files, and depending upon the application, they all have different ways of representing functionality. So the ideal is to have an entire description of your entire operational environment in metadata. So let's say a bomb hit your data center and you had to fail over to a brand new data center. You could essentially rebuild the entire thing from your metadata, and that's the idea of a codeless environment. So that's part of the story. Now, trustless is part of the security story. Zero trust essentially means that there should be no element of your infrastructure that you're assuming to be trusted. So in a more traditional security context, we have firewalls that are providing a perimeter, and within that perimeter are trusted resources. Well, we've learned that we can't trust anything inside our firewall anyway. So what do? Well, we basically assume everything is untrusted, and until we have a way of trusting some element of our infrastructure for a particular purpose. Well, in the cloud native world, the problem is that we can't trust even individual endpoints because endpoints move around, right? We can't, you say, well, if this IP address is trusted, the asset at this IP address is trusted because the IP address might change. There may not be the same IP address from one moment to the next because we're in an ephemeral environment. So we have to have identities associated with all of our endpoints, whether they are service endpoints or whether they are the consumer endpoints. And then we have to have a zero trust way of dealing with identity-based security across our entire infrastructure. So it's a new way of looking at security that essentially is zero trust within the context of abstracted endpoints.
Great. Maybe just one or two more. Someone asked, what situations would you want to migrate a monolithic app to Kubernetes?
Want me to take this one as well?
I can tell.
Go ahead. Go ahead, Simone.
Yeah, I can try. Sometimes it's cost of implementation or resource expertise in trying to take an application that is still needed in the business, but you are moving other elements of that particular application to a more modern, cloud native components or microservices. But you still have a few that you can, you need to drag along for a few more years. So you want to take the monolith, but not change the way they operationally implement the solution itself, so that even that monolith can coexist in all the goodness of snapshots and cloning and setting up a day two operation that allows you for upgrades and rollbacks that has the same exact function is very, very powerful, so that you're not waiting until everything is changed, right? Because it may take years for you to redesign that particular application. And that's, it's a big benefit that I think it doesn't come natively on, Kubernetes or other solutions. You need to architect it the way that Robin has put it together, where these elements do coexist and are managed as a one.
Beautiful. Thank you, Simone. Okay, last one for now. We do have a few more, but we're running out of time. Someone asks, does deploying Kubernetes automatically make you cloud native? I'll give that to Jason.
Well, it's a great setup because it's I guess it's a joke in IT circles. Does deploying X automatically make you Y? And everybody laughs and says, well, no, it doesn't really matter what X and Y are. So the answer is obviously no, right? Because nothing will automatically make you anything. In this case, cloud native is really much more than Kubernetes, right? So deploying Kubernetes is a good first step, and it is an essential part of moving to a cloud native infrastructure. I guess a more interesting question is, could you have a cloud native infrastructure without Kubernetes? And that's sort of it takes a little more thought. And I guess in theory, it's possible, because we're essentially defining cloud native, it's extending cloud best practice to all of IT. Nothing in that statement says, oh, Kubernetes is necessary. In practice, though, right here, so it's a difference now between in theory and in practice. In practice, when we say cloud native today, we generally mean that there's Kubernetes there somewhere, right? That we're building our infrastructure on Kubernetes. So in practical terms, that Kubernetes has become a part of the cloud native conversation, but the cloud native conversation is really broader than just Kubernetes. Deploying Kubernetes alone obviously doesn't necessarily give you anything, because there's no guarantee you're going to get it done properly.
Perfect. Great, Jason. Okay, as promised, we're well under 60 minutes. I wanted to thank both Jason and Simone. It was a great presentation beside the glitch there. As I mentioned earlier, we'll send the recording of the webinar to everyone in the next few days. And I encourage people to, I think Jason made a point about the complexity that goes into re-architecting. And if you all get some time to go to robin.io, request a demo. Nothing beats seeing the Robin platform in action, in my opinion, and you'll see how we bring simplicity to that complexity. It's pretty stunning, and so we encourage you to check that out, or also check our resources in our blog. Thanks again, and appreciate everyone for showing up.